Question 1. Through the lens of refrigerant safety classification systems, ISTA Singh is inspecting a commercial HVACR system in a medical facility. The system uses R717 ammonia, which has a high efficiency but a known toxicity. During inspection, he notices a slight odor near the evaporator coil area and suspects a leak. Which immediate action should ISTA Singh take? A. Continue the inspection while documenting the location of the odor. B. Shut down the system, evacuate the area, and initiate emergency procedures. C. Ignore it as ammonia odors are common in such systems. D. Ventilate the space and return after 24 hours for re-inspection. Answer. Correct answer, B. Explanation. R717 ammonia is classified under ASHRAE Standard 34 as a biorefrigerant indicating high toxicity and low flammability. OSHA and EPA guidelines require immediate evacuation and system shutdown when a toxic refrigerant leak is suspected. Ignoring the odor or delaying action can result in exposure to dangerous concentrations, especially in occupied buildings. Following 29 CFR 1910.119 OSHA per SM and Section 608 of the Clean Air Act, the inspector must prioritize safety and environmental compliance. Question 2. In the context of indoor air quality assessments, which psychrometric condition best indicates a high risk of mold growth within a building envelope? A. Low dew point and high dry bulb temperature. B. High wet bulb temperature with low relative humidity. C. Dew point temperature above 6 dec and relative humidity 60%. D. Dry bulb temperature below 65 dec and relative humidity below 40%. Answer. Correct answer, C. Explanation. Mold thrives in environments with elevated moisture, specifically when the dew point exceeds 6 dec and RH is above 60%. This condition causes surfaces to remain damp, providing suitable environment for microbial growth. ASHRAE 62.1 and EPA guidelines identify high RH and high dew point as key contributors to mold issues. Option C reflects both factors and is the most accurate indicator of risk. Question 3. Given the circumstances, Garcia is inspecting a rooftop HVAC unit. She observes that the insulation on the suction line is deteriorated and missing in several spots. What is the most likely consequence of this defect? A. Decreased airflow velocity in the ducts. B. Increase in subcooling at the condenser. C. Reduced compressor efficiency due to heat gain. D. Higher static pressure across the evaporator. Answer. Correct answer, C. Explanation. When suction line insulation is compromised, ambient heat enters the refrigerant line, increasing superheat and causing the compressor to work harder. This decreases system efficiency and risks overheating the compressor. It may also cause false superheat readings affecting charge assessments. According to a CAS Standard 5 in ASHRAE 15, proper insulation is critical to system performance and safety. Question 4. Contrary to popular belief, not all furnace backdrafting issues stem from improper flue design. Which of the following conditions is most likely to cause backdrafting in a gas-fired furnace? A. Flue pipe angle exceeding 45 degrees. B. Oversized heat exchanger. C. Depressurization due to bathroom exhaust fans. D. Excessive burner input beyond rating plate. Answer. Correct answer, C. Explanation. Depressurization in the combustion zone can pull flue gases back into the space instead of allowing them to vent properly. This often results from exhaust fans or tight building envelopes. The IM Section 303 and 501 and in FPA 54 stress maintaining proper combustion air and pressure balance, flue angle and burner input are factors, but indoor depressurization is the most common overlook. Question 5. During the process of diagnosing a zone control issue, Inspector Tanaka finds that a building's BAS building automation system fails to maintain individual room temperatures. What is the most likely cause? A. Inadequate refrigerant charge in the central unit. B. Faulty setpoint programming or overridden schedules. C. Cracked heat exchanger causing intermittent cycling. D. Improper duct sizing causing poor velocity. Answer. Correct answer, B. Explanation. BAS relies heavily on setpoint schedules and overrides, especially in multi-zone systems. If these schedules are incorrect or overridden manually, common in offices, zones won't respond correctly. ASHRAE Guideline 13 and BACnet protocol documentation recommend periodic control logic audits. Other mechanical issues may exist, but are unlikely to affect BAS zone responses directly as programming errors. Question 6. The central argument for detailed inspection documentation is: A. It provides clients with historical repair costs. B. It supports code enforcement authority in issuing citations. C. It ensures legal protection and clarity in liability situations. D. It replaces the need for system performance testing. Answer. Correct answer. C. Explanation. Comprehensive documentation is essential for risk mitigation and legal clarity. According to HRConquer Standard 180 and OSHA 20I and CFR 1910, inspectors must provide thorough and factual reports. In disputes or claims, detailed notes and photographs protect both inspector and client. Documentation does not replace performance testing but complements it as part of professional. Question 7. From a practical standpoint, why is it critical to discharge capacitors during HVACR inspection procedures? A. To prevent short cycling of the compressor. B. To improve amperage measurement accuracy. C. To avoid personal injury from stored electrical energy. D. To allow system refrigerant pressures to equalize. Answer. Correct answer. C. Explanation. Capacitors store high voltage energy even when the unit is off. OSHA and NFPA 7TI require discharging capacitors before touching or testing components to avoid electric shock. This is a fundamental lockout-tagout (LOTO) procedure. Failing to do so can cause arc flashes or fatal injury, particularly in systems with dual capacitors or hard start kits. Question 8. Based on the information provided by our guidelines, which retrofit would most significantly reduce HVAC energy consumption in an older commercial building? A. Installing high-efficiency condensing units. B. Upgrading from analog to digital thermostats. C. Sealing ductwork in unconditioned spaces. D. Increasing compressor capacity for peak load. Answer. Correct answer. C. Explanation. Duct leakage in unconditioned spaces is one of the largest sources of energy loss in buildings. The Act Section C0333 emphasizes duct sealing and insulation as critical to energy conservation. While high-efficiency equipment helps, stopping conditioned air from escaping has an immediate and measurable impact. Compressor oversizing increases energy use and is counterproductive. Question 9. Demonstrated by a recent inspection case Mr. Zhao encountered a walk-in freezer with warm product despite the compressor running constantly. What should be his first diagnostic focus? A. Refrigerant type and safety classification. B. Core cleanliness and fan motor condition. C. Compressor winding resistance. D. Door seal integrity and infiltration. Answer. Correct answer. D. Explanation. If the compressor is running but the temperature remains high, door gasket failures or air infiltration are likely culprits. These issues allow warm, moist air to enter, overwhelming the system's cooling capacity. As per Nate and R says at troubleshooting protocols, the inspector should check infiltration sources first before mechanical systems. Fan and coil issues may contribute, but infiltration is primary. Question 10. In what ways can a failure in a ventilation system negatively impact a hydronic heating system? A. It reduces outdoor air quality, affecting building pressure. B. It causes the boiler to overheat due to return air blockage. C. Increases combustion efficiency and lowers system load. D. It prevents the thermostat from calling for heat. Answer. Correct answer. A. Explanation. Hydronic systems depend on balanced building pressure, often influenced by ventilation airflow. If exhaust systems are oversized or intake underperforming, negative pressure develops, which can pull flue gases into the occupied space or impact combustion. This violates IMC 501.3 and NFPA 31, both of which require balanced ventilation and combustion air supply. Combustion safety and balance must be evaluated together. Question 11. With the advent of modern refrigeration monitoring technologies, Lambeth is inspecting a walk-in freezer at a restaurant. She observes frost buildup on the evaporator coil despite the defrost cycle functioning at its scheduled intervals. Which of the following is the most likely cause of this condition? A. Oversized TXV leading to liquid slugging. B. Ambient humidity entering through frequent door openings. C. Short cycling of the compressor limiting suction. D. An operative crankcase heater on the compressor. Answer. Correct answer. B. Explanation. Frequent door openings introduce moist ambient air into the freezer, which condenses and freezes on the evaporator coil even if defrost is scheduled. This is a common issue in food service environments. The ASHRAE Refrigeration Handbook recommends installing air curtains or better door management to reduce this infiltration. Oversized TSVS and crankcase issues may cause other problems, but moisture load is the primary concern, with frost buildup under functional defrost. Question 12. In light of recent developments in HVAC inspection enforcement, what is the primary purpose of requiring mechanical system components to be accessible as mandated by the IMC? A. To facilitate future equipment upgrades. B. To reduce noise transmission into occupied spaces. C. To ensure safety and effectiveness during inspection or maintenance. D. To allow flexible duct placement in confined spaces. Answer. Correct answer. C. Explanation. The International Mechanical Code (IMC) Section 306 mandates that access be provided to equipment such as fans, coils, filters, and controls to ensure safe and effective inspection, servicing, and maintenance. Inaccessible components can compromise safety, delay emergency repairs, and violate code. The rule is not primarily for noise or flexibility, but for the operational integrity of inspection procedures. Question 13. The prevailing attitude toward HVACR system energy efficiency emphasizes the importance of understanding thermodynamic laws. Which principle best explains why subcooling is beneficial in a vapor compression cycle? A. It reduces the heat rejection capacity of the condenser. B. It ensures refrigerant is fully vaporized at the compressor inlet. C. It increases enthalpy difference across the evaporator. D. It ensures only liquid refrigerant reaches the metering device. Answer. Correct answer. D. Explanation. Subcooling ensures that only 100% liquid refrigerant enters the expansion valve, preventing flash gas that could reduce system efficiency and cooling capacity. This is explained by the first law of thermodynamics, as energy balance depends on enthalpy changes at each state. The ASHRAE Handbook Fundamentals emphasizes that subcooling increases refrigeration effect and avoids premature vaporization that expansion valve performance. Question 14. Examining the consequences of improper system commissioning, Mr. Ortega inspects the heat pump system with a reported issue of poor heating performance. He finds that during heating mode, the temperature rise across the air handler is only 10 neg. What should he investigate first? A. Faulty reversing valve operation. B. Dirty condenser coils. C. Inaccurate thermostat calibration. D. Undersized return duct. Answer. Correct answer. A. Explanation. In heat pump systems, a low temperature rise in heating mode often indicates a malfunctioning reversing valve, causing the system to operate in cooling or neutral mode. The manufacturer's installation and operation manual, along with NATE certification diagnostics, point to valve position as primary suspect. Thermostat and duct issues may affect comfort, but reversing valve failure directly affects heating output. Question 15. By evaluating field-reported failures in rooftop systems, which approach should an HVACR inspector prioritize when multiple symptoms? Low suction pressure, high superheat, and loud compressor noise are observed. A. Recommend full system replacement. B. Charge system to correct superheat. C. Diagnose possible evaporator airflow restriction. D. Add oil to improve compressor lubrication. Answer. Correct answer. C. Explanation. Low suction, high superheat, and compressor noise often indicate restricted airflow across the evaporator, commonly caused by dirty filters, blocked coils, or blower issues. The result is less heat absorption, leading to excessive superheat and compressor strain, as per a manual RS and ASHRAE standard 180. Checking airflow before making refrigerant or mechanical decisions is a sound diagnostic strategy. Question 16. During the process of preparing for an HVACR inspection in a hospital, Inspector Alston ensures his tools are calibrated and PPE is ready. What critical legal reason supports this practice? A. It ensures compliance with Joint Commission building ratings. B. It fulfills OSHA and liability requirements for a safe inspection process. C. It reduces HVAC maintenance time for facility engineers. D. It guarantees faster certification under IMC regulations. Answer. Correct answer. B. Explanation. Under OSHA 1910 subpart I, inspectors are required to what EPE appropriate to the environment, especially in healthcare facilities. Ensuring tool readiness and safety practices helps mitigate legal liability and ensures compliance with both OSHA and NFPA 7I. The practice isn't about speeding up processes or certification timelines, but rather ensuring safety and legal adherence. Question 17. To better understand the impact of metering device performance, which of the following symptoms is most indicative of a stuck-open expansion valve in a typical AC system? A. Low superheat, high suction pressure and reduced cooling. B. High head pressure with no subcooling. C. High superheat with low suction and frozen evaporator. D. Normal pressures with elevated amp draw. Answer. Correct answer. A. Explanation. A stuck-open DXP allows too much refrigerant into the evaporator, causing flooding, reduced superheat, and elevated suction pressure. Cooling is reduced because the coil can become saturated and less effective. This condition is detailed in HVACR troubleshooting guides and EPIS section 600A exam prep. The resulting liquid floodback may also damage the compressor if unresolved. Question 18. According to EPIS Section 608 requirements, what must an HVACR inspector verify when inspecting a system with a refrigerant leak exceeding the threshold for a comfort cooling system? A. That leak repair is deferred for 1 year under emergency exemption. B. That leak is documented and a retrofit or repair plan is in place within 30 days. C. That refrigerant is topped off every 30 days to maintain pressure. D. That system is replaced immediately regardless of cost. Answer. Correct answer. B. Explanation. Per EPA 40 CFR Part 82 Subpart F, if a comfort cooling system leaks more than 10% annually, the owner must develop and document a repair or retrofit plan within 30 days. Topping off is illegal and full replacement is not mandatory unless repair is not feasible. Failure to act results in penalties. Inspectors must review logs and repair records for compliance. Question 19. The effectiveness of ventilation design is often evaluated by measuring airflow at registers. Which of the following is the best method to validate proper airflow balance during an HVACR inspection? A. Using a smoke pencil to detect turbulence. B. Counting the number of diffusers per zone. C. Using a flow hood to measure CFM at each supply. D. Measuring the system's total static pressure. Answer. Correct answer. C. Explanation. A flow hood is a calibrated tool used to measure actual cubic feet per minute (CFM) delivered at diffusers. This helps inspectors assess system balance per ACAM Manual D and NEB standards. While static pressure and smoke tests have their place, only CFM measurement confirms compliance with ASHRAE 62.1 ventilation rate procedures. Question 20. Throughout the course of evaluating a commercial ERF system, Inspector McAllister finds that the system occasionally shuts down during mild weather with no error code. What advanced characteristic VRF technology may explain this behavior? A. VRF systems are incompatible with low ambient operation. B. Heat recovery function misroutes refrigerant to idle zones. C. Load diversity is too low for inverter modulation to function. D. The compressor requires periodic oil equalization shutdown. Answer. Correct answer. C. Explanation. Variable refrigerant flow (VRF) systems rely on load diversity to operate efficiently in light load conditions, e.g. spring or fall. The inverter may not modulate low enough, leading the system to temporarily shut down to prevent short cycling. This is well documented in manufacturer commissioning guides and the ASHRAE RP 1607 is interpreting this as a fault is a common inspection error. Question 21. Considering the evidence from recent system failures, Mr. Davis inspects a packaged rooftop unit and notes that the refrigerant is superheated excessively at the compressor inlet. What underlying thermodynamic issue is most likely causing this? A. Excessive refrigerant charge increasing liquid flooding. B. Reduced evaporator airflow limiting heat absorption. C. Low outdoor ambient temperature increasing condensation. D. Faulty condenser fan causing head pressure to rise. Answer. Correct answer. B. Explanation. Excessive superheat at the compressor inlet usually indicates insufficient heat absorption in the evaporator, often caused by reduced airflow due to dirty filters or blow-up malfunction. This results in refrigerant staying longer in vapor phase and increasing temperature, stressing the compressor. ASHRAE Handbook Fundamentals and HVACR Manual RS support airflow checks first in superheat diagnostics. Question 22. In an effort to troubleshoot a failing air conditioning system is new and observes a compressor that frequently trips on overload protection. What is the most probable electrical issue she should investigate? A. Open circuit in the thermostat wiring. B. Short cycling due to a stuck contactor. C. Motor winding insulation failure causing high current draw. D. Insufficient refrigerant charge reducing pressure. Answer. Correct answer. C. Explanation. Frequent overload trips often indicate motor winding degradation or shorts, causing the compressor motor to draw excess current. Inspectors must measure winding resistance and insulation resistance per NEC Article 430 and NEMA standards. Other options may cause issues but not repeated overload trips specifically related to motor electrical health. Question 23. By evaluating the impact of equipment selection, Mr. Patel inspects the ductless mini-split system installed in a multi-room office. He notices uneven cooling between rooms. What is the most common cause? A. Incorrect refrigerant type causing coil freeze-up. B. Improper sizing or placement of indoor units. C. Poor electrical supply causing compressor failure. D. Duct leakage reducing airflow volume. Answer. Correct answer. B. Explanation. Ductless mini-split systems rely on multiple indoor units sized and positioned to match individual room loads. Improper sizing or poor placement causes uneven cooling. ASHRAE Standard 90.1 emphasizes load matching and unit zoning. Duct leakage is irrelevant here due to no ductwork, and refrigerant or electrical issues usually affect system operation, not zoning. Question 24. When faced with working on an active HVACR system, which OSHA standard requires a lockout-out procedure to be in place before maintenance. A. OSHA 1910.147 Control of hazardous energy. B. OSHA 1926.524 Protection. C. OSHA 1910.95 Occupational noise exposure. D. OSHA 1910.120 Hazardous waste operations. Answer. Correct answer. A. Explanation. OSHA 1910.147 mandates lockout-out (LOTO) procedures to prevent accidental energization of machinery during maintenance, protecting workers from electrical or mechanical hazards. This is fundamental in HVACR inspection and repair to ensure safety. Other OSHA standards apply to different hazards, but not specifically energy control. Question 25. To what extent does proper capacitor function affect the starting torque of a single-phase HVACR compressor motor? A. Capacitors regulate the voltage across the compressor windings. B. Capacitors provide the phase shift required to generate starting torque. C. Capacitors reduce compressor amperage draw during steady state. D. Capacitors protect the motor from voltage spikes during startup. Answer. Correct answer. B. Explanation. Capacitors in single-phase motors create a phase-shifted current in the auxiliary winding which generates the necessary starting torque. Without this phase shift, motors fail to start or have reduced torque. This principle is covered in NEMA MG and HVACR electrical training manuals. Options A, C, and D describe different capacitor functions but don't explain starting torque. Question 26. While evaluating temperature splits in a residential split system, Lee finds the supply air temperature is only 4 degrees cooler than the return. According to best practices, what should she suspect? A. Undersized condenser causing inadequate heat rejection. B. Refrigerant undercharge or airflow issues reducing cooling capacity. C. Improper thermostat calibration causing false readings. D. Electrical control failure preventing compressor cycling. Answer. Correct answer, B. Explanation. A typical temperature split dt for cooling is 152°. Low dt of 4°, usually indicates refrigerant undercharge or poor airflow due to dirty filters or duct issues, both reducing heat transfer efficiency. A CAM manual T and ASHRAE guidelines emphasize checking refrigerant charge and airflow before controls or sizing concerns. Question 27. The fundamental question is, how does improper duct sealing affect the energy efficiency and indoor air quality of an HVAC system? A. It reduces airflow velocity without affecting energy use. B. It increases heat and cooling load and allows contaminant infiltration. C. It improves system capacity by adding outdoor air. D. It only affects static pressure but not thermal comfort. Answer. Correct answer, B. Explanation. Leaky ducts increase energy consumption by allowing conditioned air to escape and unconditioned air to enter, raising heat and cooling loads. They also reduce IAC by permitting dust, allergens, and pollutants to infiltrate the system. ASHRAE 62.1 and IAC stress duct sealing is critical to energy and IAC performance. Question 20. Under the assumption that regional codes vary, what is a key difference often seen between the UNC and the IMC regarding combustion air requirements? A. UNC allows sealed combustion only in commercial applications. B. IMC requires a minimum number of combustion air openings for all gas appliances. C. UNC has more prescriptive combustion air sizing based on appliance input ratings. D. IMC does not regulate combustion air for forced air furnaces. Answer. Correct answer, C. Explanation. The Uniform Mechanical Code UMC tends to provide more detailed, prescriptive combustion air sizing methods based on appliance input ratings and building construction. The International Mechanical Code IMC is sometimes more performance-based. Inspectors must be familiar with the local adopted code. Both codes require combustion air but differ in specifics. Question 29. While performing a visual inspection, Mr. Johnson notices corrosion on the refrigerant lines near the compressor housing. What should be the inspector's next step? A. Advise immediate replacement of the compressor. B. Check for refrigerant leaks and assess insulation integrity. C. Remove insulation to improve heat dissipation. D. Increase refrigerant charge to compensate for potential leaks. Answer. Correct answer, B. Explanation. Corrosion often indicates moisture intrusion or refrigerant leakage. Inspectors should check for leaks with proper detection tools and verify insulation condition to prevent further damage. Premature compressor replacement is costly and may be unnecessary. Increasing charge without repair violates EPA regulations. Question 30. To illustrate this point, ISCATO inspects a hydronic heating system and finds uneven temperature distribution in the zones. What is the most probable cause? A. Air trapped in the system preventing proper flow. B. Thermostat calibration errors. C. Insufficient boiler firing rate. D. Excessive insulation on pipes. Answer. Correct answer, A. Explanation. Air trapped in hydronic piping creates airlocks that impede circulation, causing uneven heat delivery to zones. Bleeding air is a standard corrective measure per ASHRAE Handbook, HVAC Systems and Equipment and Hydronics Institute guidelines. Calibration and firing rate may affect overall heat but not zoning imbalance caused by trapped air.